Topic 7.2 Summary, Part 3, Chain Reactions and Fusion. Okay, what I'd like to focus on in this slide is when you have nuclear fission, you can easily get a chain reaction. So let's suppose we have a neutron that comes in, strikes a uranium nucleus, which splits and gives off 3 neutrons. They go off in different directions. And if some of those neutrons happen to hit other uranium nuclei, then those nuclei in turn will split, and we get more free neutrons, which in turn will hit yet more uranium nuclei. And pretty soon, I think you can see, we can get a pretty fast-moving chain reaction here. So a huge amount of energy is given off in a short amount of time. Let's take another look at a fusion reaction. In this case, we have a neutron striking a uranium-235 nucleus, which splits, and into a rubidium-90 and a cesium-143 nucleus, and we have 3 neutrons that are liberated. As it turns out, the neutron that strikes the uranium-235 nucleus has to be going the right speed in order to be absorbed. A slow neutron will be captured by the uranium nucleus. Fast neutrons will not be captured, and they first have to be slowed down so they're going the right speed. That slowing down process is called moderating the neutrons. Again, these neutrons that are rejected have a lot of kinetic energy, and if they strike other uranium-235 nuclei, which they're likely to do, then when those nuclei in turn split, you get more neutrons released and so on. And it's pretty easy to see that we can get a chain reaction, and this releases a huge amount of energy. In fact, when 1 kilogram of uranium-235 fissions, it gives off the same amount of energy as 20,000 tons of TNT, high explosive, exploding. A stunningly huge amount of energy. An uncontrolled nuclear fission reaction produces a fission bomb, which is often called an atomic bomb. The bomb that destroyed Nagasaki, Japan, had a TNT equivalency of about 15 kilotons, 15,000 tons of TNT. If the number of neutrons striking uranium-235 nuclei is controlled, a self-sustaining nuclear reaction can be maintained. This occurs in a nuclear reactor. So in a nuclear reactor, we have a controlled chain reaction producing heat, which is used to boil water to make steam to turn a turbine and generate electricity. The second type of nuclear reaction is a fusion reaction. In a fusion reaction, you have 2 light nuclei combining to form a heavier nucleus. Nuclear fusion is a source of energy in stars. Most stars fuse hydrogen and possibly helium. The series of reactions that power our sun is called the proton-proton cycle. We'll probably talk about the proton-proton cycle later in the year when we do astrophysics. In a nuclear fusion reaction, we have 2 small nuclei will combine together to form a heavier nucleus. So in this particular example, we have 2 different types of hydrogen. We have hydrogen 2 here, deuterium, and we have hydrogen 3, tritium. And the hydrogen 2 and the hydrogen 3 collide at extremely high speeds. This takes a lot of energy because the protons in the nuclei would repel one another. So it takes very high temperatures to create nuclear fusion. So these guys smash into each other, and we end up with a nucleus of helium and a leftover neutron. The helium is not radioactive. We have a lot of energy being given off, and we have no radioactive byproducts. So that's the big advantage of nuclear fusion. So we just talked about so-called atomic bombs. Atomic bombs are powered by the fission of uranium. What we call hydrogen bombs are fusion reactions where you have hydrogen fusing into helium and giving off even larger amounts of energy. Fusion reactors do not exist today, but one day they may provide a cheap source of energy with few radioactive byproducts. So again, one big disadvantage of fission is that the products that are left over are radioactive. So nuclear power plants of today, the leftover fuel is very radioactive, and getting rid of it is a problem. If we can master the fusion reaction, then the byproduct is helium, which is... Okay, that's it. See you next time, except I have a word of the day for you. Today's vocabulary word is avoidable. Avoidable, what a bullfighter tries to do.